All right, before we begin today's lesson on prime factorization, let's recall first what prime means. So prime means any number that can only be multiplied by 1 and itself. So let's take a couple of examples here. Let's try 4. Is 4 a prime number? Well, you have 4 times 1, but you also have 2 times 2 that both equal 4. So therefore, 4 is not a prime number. Let's try another one. Let's try 7. Well, we have 7 times 1. That equals 7. Is there anything else we can multiply with another number in order to get to 7? There is not. Therefore, 7 is a prime number. So that's the definition of a prime number. The only factors of a prime number are itself and 1. All right. So now that we've established that, let's look at prime factorization in the lesson. Here we go. We're on lesson 1.2, which is found on page 9 in your textbook, your large textbook. The essential question for today: how do you write the prime factorization of a number? Secret codes are often used to send information over the internet. Many of these codes are based on very large numbers. For some codes, a computer must determine the prime factorization of those numbers to decode the information. The prime factorization of a number is the number written as the product of all of its prime factors. All right, so here's one way, is to use a factor tree. Okay, and this is our little reminder. A prime number is a whole number greater than 1 that has exactly 2 factors, itself and 1, like the number 7 in our example. All right. The key for a code is based on the prime factorization of 180. Find the prime factorization of 180. Choose any 2 factors whose product is 180. Continue finding factors until only prime factors are left. So at the bottom of our factor tree, there are only going to be prime numbers at the bottom. Okay. 10 times what number is equal to 180? So that would be 10 times 18 equals 180. So that can be our first 2 factors. Now, is 10 a prime factor or a prime number? It is not. It has factors besides 10 in itself. It has 2 and 5. Does 2 have any more factors besides itself and 1? No, it does not. So 2 is a prime number. 5. Is there anything you can multiply together to get 5, the product 5, besides 5 in itself? 5 and 1? No. So 5 is also a prime number. Now let's take a look at this side, 18. We have it can be broken down to 6 and 3, those 2 factors. Can 6 be broken down further into prime numbers? Yes, it can. 2 times 3 makes 6. 3, however, is a prime number. Therefore, we just write the 3 there. Now, when writing out our factors for our solution, we always start with the largest factor first. So we're going to write the 5 first, and order does matter. Then we have 2 3s, so we're going to go 3, 3, and I cross these out to keep myself organized and know which ones I've used. And then we have 2 2s, 2, 2, and this is the prime factorization of the number 180. Now this isn't the only way we could do it. It doesn't have to start with 10 and 18. We can start with different numbers. If you're realizing, well, 180 is an even number, you can start with 2 times 90. That equals 180. So we can do 2 and 90. 2 is a prime number, therefore it doesn't have any other factors involved. Here we have 90 can be broken into 2 and 45, those two factors. 2, once again, is a prime number. Here we have 3 and 15. 45 can be broken down to 3 and 15. 3 is a prime number. And 15 can be broken down to 3 and 5. Notice that they're in a slightly different order, but they're the exact same numbers. If I put these in order from greatest to least, once again, I have 5, 3, 3, 2, and 2. I came up with the exact same answer. So if you're doing the prime factorization correctly, even if you start by breaking down slightly differently in the beginning, you will always come out with the right answer at the end. So the prime factorization of 180 is 5 times 3 times 3 times 2 times 2. Okay, let's take a look at the next page. Here's another way, the ladder diagram method. Okay, the key for a code is based on the prime factorization of 140. Find the prime factorization of 140. Choose a prime factor of 140. Continue dividing by prime factors until the quotient is 1. All right, so this is just a different way of doing it. Some people prefer this way, so we're going to learn it. We begin with 140 right here, and we can pull out a 2. We know that this is an even number. 2 times what gives us 140? Well, 70 does, right? 2 times 70. Once again, I can pull out a prime number from this, 7, and I have 10 left over. Okay, so now with 10, that can be broken down with a 5 and a 2, and then 2 times 1 is 2. So now these are our prime factors of 140. So our final answer, we're going to put them in order from greatest to least. All right, so the prime factorization of 140 is 7 times 5 times 2 times 2. Okay, once again, with the ladder method, same number. If I started by pulling out a different number, I noticed that it ended with a 0, therefore it's divisible by 5. That's okay. We can pull out a 5 as long as we are only pulling prime numbers out in the ladder. It will come out to be the same answer. So 5 times, this one's a little more tricky though, in my opinion. I don't know what 5, how many times 5 goes into 140, but I can do a little margin work, and that's okay. 5 goes into 14 twice. 5 goes into 40 8 times. All right, so I figured out that this right here is 28. Well, 28 is an even number, so the easy factor to pull out is, prime factor to pull out is 2, which left us with 14. 14, once again, is an even number, but we're going to pull out the 7 and leave 2 behind, and then 2 and 1. So once again, we ended up with the same prime factorization, just in a little different order. That's okay. When you write out the final answer, remember to put the biggest prime factor first and the smallest one last. Okay, 2 more quick examples and we'll be done. Okay, starting with 18. Well, 18 can be broken down to 6 and 3. 3 is a prime number, so it just goes all the way down. 6 can be broken down to 2 and 3. Great, so now we're going to write out our prime factorization, starting with the biggest number first and work our way down to the smallest prime number. And there you have the prime factorization of 18. What if I had done this? Is that okay? Absolutely. Here I have 3 and 3 and 2, and guess what? I still have the same numbers. All right. Now we're going to use the ladder method to do the prime factorization of 42. So if I pull out a 2, because I've noticed that this is an even number, I have 21 left over. Then I pull a 3 out of the 21, I end up with 7. 7 only has one number times itself for a factor. Okay, and once again, look for the biggest one, 7, the greatest value, 3, 2, making sure it's all in order. Okay, wonderful. Now let's take a look at our notes. Here we have 1.2 prime factorizations. So we have two methods. The factor tree, we break the number down to its prime factors by branching out in a tree-like form. It looks a little like a Christmas tree. And there's our example. Or we can use the ladder diagram, pull a prime number out at each step of the ladder. So making sure that all of these numbers out here are prime numbers. If I have 180 and I pull out a 10, that doesn't work because 10 is not a prime number. It has to be a prime number that you pull out. All right, and then you order. These are not ordered from greatest to least. I did them from least to greatest. Turn those around in your notes. All right, the last step for both methods is to put the numbers in order. All right.